Hi everyone, thank you for joining. Today we're going to do a question on a STEP paper, a Cambridge Maths entrance paper. It seems like quite a complicated question, but it's a manipulation of notation that we've learned at A level, college level integration course. So, if you'd like to pause the video here and try it yourself first, then we could go with it together. Right. Okay. So the first part is that what seems quite natural thing to do here, because you have f of something and we have f of t. So I think it's quite natural to define t to be x squared plus 1 to the half plus x. And we want to replace why did we do that? Because now f of that simply becomes f of t. And we want to replace dx with dt. So the best way to do that is look at dt dx, which is equal to half, that's x squared plus 1 minus a half times 2x plus 1. If you simplify that, 2's will go. That would be x over x squared plus 1 to the half plus 1. Common denominator, x squared plus 1 to the half divided by x squared plus 1 to the half. That's the same as if you t minus x. Why? Because if you look at that, that's the precise definition of t. And then if you make that the subject in this definition, you get t minus x. So we don't want any x on the right hand side, as you can see. So we need to eliminate this x here. And how do we do that? Using the definition again, t minus x is equal to it's equal to x squared plus 1 to the half, and then squaring both sides, we get t squared minus 2tx plus x squared is equal to x squared plus 1. Cancel x squared, make t the subject. Well, we have t squared minus 1 is equal to 2tx. That implies t squared minus 1 is over 2t is equal to x, right? If we sub that in there, we'll get dt dx is equal to t divided by t minus t squared minus 1 over 2t. We need to be careful with the brackets here. That's the same as 2t squared over 2t squared minus t squared plus 1. That's equal to 2t squared over t squared plus 1, right? So we want to make dx the subject. That means dx here is equal to t squared plus 1 over 2t squared. That's the same as 1 over 2. Sorry, there should be dt there. 1 over 2. We have t squared plus 1 over t squared dt, which is the same as 1 over 2. 1 plus t to the minus 2 dt. Right, so integrate f of x squared plus 1 to the half plus x dx is equal to, we have f of t multiplied by 1 over 2, 1 plus t to the minus 2 dt, right? And the limits for 0 to infinity, if you go back to definition of t, which is here. So clearly when x goes to infinity, t goes to infinity. But when x is 0, notice t will be 1, right? We will have square root of 1, which is 1. So that means we have 1 to infinity. We solved that question. Okay, this is what we wanted to show. So the second part of the question says, hence or otherwise. Let's do hence. We want to use the result that we've just proved. Show that this is true. So again, if you look at the resemblance of that with that, immediately one thinks of defining a function this way. Okay, because notice is to the power of minus 3. So if we define f of x to be x to the minus 3, that implies f of t is equal to t to the minus 3, right? And integrating f of x squared plus 1 to the half plus x dx from 0 to infinity is the same as integrating 0 to infinity x plus 1 to the half plus 1 plus x to the minus 3 dx. I just used the definition of that. So what this is saying is that if you plug in x, it's just going to raise to the power of minus 3, and if you plug that in for that function, you get that raised to the power of 3, right? But remember, we've shown in the first part that this is the same as 1 to infinity f of t. There was 1 over t outside, sorry, 1 over 2, so 1 plus t to the minus 2 dt, right? So for this given function, we have f of t to be t to the minus 3 and 1 plus t to the minus 2 dt. Okay, so all we have to do is do this integral. That's equal to 1 over 2 t to the minus 3 plus t to the minus 5 dt. So if we do the integral, we get t to the minus 2 divided by minus 2 minus t to the minus 4 over 4 from minus infinity to 0. Now notice 1 over t to the minus 2 is equal to that, and as t tends to infinity, this will tend to 0. Similar, the same argument for t to the minus 2. Sorry, t to the minus 4. Okay, so that means we will have 1 over 2 when we sub in infinity, or a very large number, I should say. You get 0 minus, and then when we, this should be infinity, 1 to infinity, I apologize, the limits 1 to infinity. I'll just double check that I got. Yes, so 1 to infinity, isn't it? Yeah. Okay, so that means, right, what we have here now is when t is 1, you simply get minus a half, minus 1 over 4. So minus, that will give you plus, minus a half. We have minus, that is minus 3 over 4. So that gives you 3 over 8 as required. Yeah. Right, so let's double check that. Okay, excellent. Yeah. Okay, well, I hope you liked it. I hope you enjoyed it. And I look forward to seeing you in my future videos. Thank you.